How's it going? I'm Mike. I'm going to go over Boyles and Charles Law today. First, we'll start with Boyles Law. Boyles Law deals with volume and pressure when temperature is constant. What Boyles Law states is that when the volume of a container holding gas is increased, the pressure of that gas inside the container is decreased. And when the volume of that gas, or of that container I should say, is decreased, the pressure of the gas is increased. Another way to say this is that they are inversely proportional to one another. Pressure is caused by molecules smashing up against walls of the container. So say we have a container, and here's some gas molecules up in here, and they're hitting the sides of this, and they're causing pressure. If that container was to be pushed down by some force or anything, maybe like a syringe with the plunger pushing down, whatever's inside that, whatever gas, the molecules, the number of the molecules stays constant. So there's the same amount of molecules, and they're hitting the sides of that with more per unit. So there's more of these hitting the smaller volume, which results in more pressure. So as the volume goes down, the pressure goes up. Now if we had a bigger container, it would still be the same amount of molecules, but there would be more space, so they'd be hitting less space, there'd be more space to move around, which would result in less pressure. So, another way to say this would be pressure times volume equals constant. So lowercase k, remember to keep it a lowercase k. If you make it an uppercase k, this actually means Kelvin, which we'll talk about later in the video. But for now, let's just deal with PV equals k. K is a constant, so k is a constant for a certain type of gas that depends on mass of gas and temperature. So let's look at a graph involving Boyles Law. So as you can see here, this is a graph, Boyles Law. So, let's say the volume is at 1, right? That means the pressure is at 1. 1 times 1 is 1. Now let's say the volume would be at 2. The pressure would be at 1/2. 2 times 1/2 equals 1. So this proves that P1 times V1 equals P2 times V2 at any point in the graph. And that's Boyles' law equation. Now, let's talk about Charles' law. Charles' law deals with temperature and volume when pressure is constant. So what Charles' law says is, if there's a gas trapped in a container, if the temperature increases, the volume increases. If the temperature decreases, the volume decreases. Let me show an example of that. If you had gas in a container, here's the molecules again. You put it under a flame. These molecules will start moving around a lot faster and a lot harder, and will be pushing against the sides more harder. So, if the pressure is going to stay constant, this container is going to have to move out. It's going to push out. And that basically proves that When temperature increases, the volume decreases. So, when solving a problem dealing with Charles' Law, it's important to remember to use Kelvin's Law, as we mentioned earlier in the video. Negative 273.15 degrees Celsius is the lowest possible temperature. You do not want to use this when dealing with problems or any negative temperature because it could result in a negative volume. And you don't want that. It doesn't make sense to have a negative volume. So what you do is you deal with Kelvin. Kelvin starts at absolute zero. And absolute zero of Kelvin is equal to negative 273.15 degrees Celsius. This prevents us from having any negative temperatures. So if you want to convert a degree Celsius to a degree in Kelvin, all you do, here's an example, you just add this to the given temperature. So we have 30 degrees Celsius. You just add 273.15 degrees to it. You get 303.15 degrees Kelvin. So that's an example of how you convert into Kelvin. So let's look at a graph using Charles' Law. Okay, so as you can see, this is basically a straight line. So 180 goes up to about, let's say, 7 there. And when the temperature is negative 60, it goes up about here. If you look at it, you can see that when the temperature increases, the volume increases. So this proves that V1 over T1 is equal to V2 over T2, which is the Charles' Law equation. So I hope you learned something today, and that concludes my Charles' Law and Boyles Law lesson. Thank you.